So let me introduce him. Dr. Debaish Roy is working as a research scientist in IMD, India Meteorological Department at New Delhi. And then he was working with me as a PhD student. And after that, he joined IMD. He worked on soil moisture mapping by using remote sensing. This was his core area of expertise. And he used the open source data and softwares for his own PhD work. He was working with me, as I said, and then we are also in touch because the IMD is located in New Delhi and it is not very far from this place. So I requested him, okay, this session to be dealt with the data sources, open source, and then he will give you an introduction. Okay, here about him, his area of expertise is remote sensing and agrometeorology, and he is very young. So his awards and recognitions are not many, but even then there are few. He is very hardworking, and I think that you will be really benefited. So this part is mostly the giving an introduction of the data sources. What are these available? So he will tell you what are the availables, what are its utility, and then how you can get access. So I request Debaish to take. Yeah, the floor is yours, please.
Thank you, sir, for giving me the introduction about me. So, today's session I will.
Roy is audible.
So I am audible. Hello, everyone.
Yes.
So, today's session I will cover today's session I will cover the introductions to open source software program and the data. So this is the content I have to discuss this session. So first of all, introductions to open source software, then download and installation.
You share the screen first. Share, the screen is already shared. Yes, share. So all of you can see the screen.
My screen is visible.
Yes, yes.
Yes, it is.
So, how to download and install open source software, and then data formats are available for use of different purposes and their utility, and then important data download links. So first of all, we need to know what is the open source software and the data. So Richard Stallman in 1985, who discovered or founded the open source software programs for promoting the idea of software freedom. The concept introduced free software that emphasizing the users freedom to run, study, and modify, then distribute software. And the open source software, that is a type of software where the source code is made freely available to the public domain, and anyone can in this spec modify and enhance the software. And then why we use this open source software? Because these are came into operations when the limitations of proprietary software and where the source code is not often accessible. So this is highly controlled by the software vendor. So that's why we go for free software. So this is the open source software available to access easily by the users. So first of all, this is a QGIS, means quantum GIS, which is freely available software that is mainly used for making a spatial data analysis and any geographic data analysis you can use. Then R platform, this is the R and R Studio. This is the two platform which can use the data visualizations and also spatial making and also different types of machine learnings you can do from this platform. And this is Panoply. This is mainly uh, 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 available in the art data. Again, that is used by NASA. So this is mainly for use for visualizations of different spatial data, like that read data, there is SDO file format data, and then raster data. Okay, that's mainly needs only SDF, read, and NC format. Okay, then come to the Python. It's a very popular right now in the programming community. So it's programming language which can be uh, integrated with the Anaconda navigators. It is the Anaconda navigator is a integrated application platform which is used for Python programming language and any and their executive and writing before and all these operations are
My
doing
slide
in
is not progressing.
Yes, just one minute.
Ah, yes.
Let's say. So you come here. So, thank you. Share. Yeah, please wait. There is some technical glitch.
You may send it to Debaish. It will be easier.
Okay, so the Bashish we have just started, right? So I should keep track of time from now onwards, right? 3:13 or 3:15.
Yeah, we have started on time, but only there are some technical issues. So
Okay, okay. I'll keep a track of time from this
slides,
time.
yeah. Okay, the slides are getting frozen, so that's what issue is there.
Okay.
The
Also,
only
for the participants, if you want, you can let us know if you want the resource person to take the entire presentation in one go. Would you like the resource person to stop at some point of time and ask something, elaborate on something? Just let us know, make it a bit more interactive for us, okay? It need not be a monologue from the end of the resource person. It has to be a dialogue. That is the whole idea of having a training program. So please keep raising hands, keep asking questions, keep
yeah, the second.
interrupting in between as and when you requiring.
Now you can see like next direction. Next way. So yeah. Slide shows what it shows.
Are we good to start?
No, again, start. Choose.
You have something to ask, Mr. Abakar?
Yes, meanwhile the issue get fixed, I have a question to the first presenter, Dr.
Dr.
Debaish.
Debashish.
Yeah.
Yes, I think he can address your query. Please, Debashish, we have a query for you from the participant.
Yeah, my question is the following concerning soil carbon in general. Do you think it's possible to have a map of soil organic carbon, and how deeper could we go if so? I mean, in terms of soil depths, with using remote sensing.
Debashish,
Okay, Mariko, could you please repeat?
Yeah, my question is, do you think it's possible? Can you hear me?
Yeah, I can hear you.
Yeah, I was asking if it's possible to map soil carbon, and how deeper could we go in terms of soil depths? Yeah.
Question was not clear to you, Debashish. Can Mr. Abakar type it out?
No, I think I can explain. So what he was
Alright.
asking is about the soil carbon mapping. Is it so, Mariko?
Yes.
Okay. So yeah, the remote sensing can very well be employed into that one, the soil carbon mapping. So as I told you, that it is basically you can say you need to integrate the soil data as such, like say soil organic carbon you were talking about, which is from your soil sampling and your analysis in the lab, and also the covariates which are explaining the soil organic carbon in the field. So you need to have soil depth, you need to have soil organic carbon field data sampling, which is of any organic carbon. If you are talking about the total organic carbon, talking about the oxidizable organic carbon, and also the covariates. Like say you have the vegetation there, you have other collateral or you can say supporting data, like say the soil clay content, which is very important for the soil organic carbon, because there is always a clay organic carbon relation, is called clay organic carbon complex. So those variables need to be looked past, that which variables are required, which has a direct link or relation with the soil organic carbon. So when you are using the digital soil mapping procedure, then apart from the field level different points data which you are taking from the field and analyzing these for a specific, let's say, soil carbon, you need to also look into other factors which data is available, for which the data is available. Okay, Mariko? So there are standard procedures for most of the soil parameters. Organic carbon is very important of them. You go through and then you devise your own, depending on that which type of soil you are dealing with, or what kind of crop is there, or which facility do you have. Yeah. Nakib?
Is that clear for you, Mr. Abubakar?
Yeah, it is. I understood that it has to go along with field measurement. And for the second question regarding the depths, I think this has to go also with the soil measurement, the physical soil measurement. For instance, let's say if your depth is 1 meter or beyond 1 meter. So yeah, that was the second question. And yeah, it's
So
clear.
for
Thank you.
all the cases, you need to have a legacy data or need to have your own data, which is possible.
Yeah.
So that's okay, but at the same time, you can use many covariates or many, you can say, very variables, environmental variables, which are you can say which demonstrates that the soil organic carbon will be there, or this is some sort of relations between those variables and the soil.
Okay, thank you.
Are we all set with
Yeah.
the presentation? Are we all set with the presentation? Okay.
Yes.
Okay. So I think we can start off with the session. It's 3:21. Have we already introduced the speaker, Debashish?
I have introduced Jita.
You have already introduced the speaker?
Yeah, I have introduced Jina. Yes.
Okay, great. So you can carry on with the next session, Mr. Debashish Roy. You have an hour of time since we have started at 3:22. I'll request you to wind up by 4:22. I will be giving you a heads up at 40 minutes and then again at 50 minutes. Over to you, sir.
No, Jina, one thing, yeah, that let him cover by 4, 5 or 4:10.
Okay, so I mean, it's your discretion. If you can get it done well and good, we can be on time.
Yeah.
I will be giving you a heads up by 3:50 so that you have a track of time.
Okay. Please go.
All right, so over to you. And again, requesting all the participants interact, ask. Don't make it a monologue. It has to be a dialogue. That is the whole idea of having this training session. Keep asking the speaker in between if you feel like. Over to you, sir.
So this is the open source software and programming language which can be used various fields, including remote sensing, GIS, and also data analysis. There's a number of packages available using R and Python. That is machine learning as well as deep learning. All the packages are available, and these Anaconda navigators, which helps to execute all the programming languages through Python language as well as RStudio. So these are available in open. So here I've shown that QGIS geographical user interface. So this is the basic interface. So during you analyze using you can understand this, or you need to understand all these tools and panels are present in the interface. So first of all,
No, you can.
So you can see that the hand tools works, which can browse your any raster data on any maps in the project, and then there's a lot of browse panels is there, which can help us define layers and with the geo package, which management the environment and vector files. So from there you can manage all these layer that can be stored in these panels, and these are then layer panels and table contents. Here all the raster and spatial objects are shown here, and this there is on the right hand side, this is posting toolbox. These are use different types of toolbox are there, including vector analysis and raster analysis and network analysis and layer tools, and with different libraries are installed in their hosting toolbox, like GDAL, GRASS. And on the right corner, you can show the map coordinate systems and positions, which map coordinate systems are in the show here during this geometry analysis. So and also it shows the map scales. This is that middle portions of this shows the map scales, where how the scaling the maps on this QGIS platform. Next one. This is the RStudio platform. So here you can see 4 windows are there: source, then console, then environment or history, then files, plots, packages. So this is the geographical interface of R. So here you can in source you can write your code, and then click to the run and send your code to the console. Here you execute the your code in the console, and then this is the there is a what you have write in the source that can be displayed in the environment or history. Here you can see the objects that you are in working space. So the fourth one, the files or plots, packages, and helps. You can see the file directories or view the plots, and see your packages and access our help. So you can, from this you can directly see the plots, which package are installed or not installed, and already installed in the user phase. So this is the whole thing of the RStudio. Next. This is the integrated applications of different platforms, which you can see you can run also R from this integrated platform named as Anaconda Navigators. It's have different launch applications, including Jupyter Notebook, PowerShell from Jupyter Lab, and PyCharms. All those things are integrated and launched here. So most of the data scientists and then community uses the Jupyter Notebook and PyCharm. And the PyCharms mainly they have used the only proportional things that when you want to develop the web or any others you want to create there. And this is a very suitable platform to develop something as a software, as a web, like that. Next one. So the why we use R and Pythons. So R basically used for data scientists as a statistical analysis, and these have extensive libraries like ggplot to deep layer tidyverse, and for use for these data manipulations and visualizations. Whereas R excels in the data visualizations, offering advanced plotting capabilities, and also the creations of interactive web applications for data explorations. Tool like using the signing. Then Pythons. Why we use Pythons? That is mainly used for web developments. I already told the automations and software developments, and it's had a lot of power to machine learning analysis using the packages like pandas, numpy, skitlearn, tensorflow, and keras. These are most popular packages are available for data science manipulation. So then and then integrations and development. It can easily integrate with the web applications and databases and various systems. Next one. So then why we use QGIS? Because it is a open source and user-friendly interface and extensive functionality, and it supports comprehensive tools for spatial analysis and mapping and visualizations, and it has interoperability and compatibility. It can support wide array of file formats and databases, ensuring the compatibility with other GIS and spatial data softwares. Customizability and extensibility. These are highly customizable and allowing users to tailor the interface and functionality to their specific needs. And cross-platform availability. QGIS runs with multiple operating systems, including Windows, Mac OS, Linux, providing flexibility for users regardless of their preferred platform. So it can integrate different libraries. I already told that in QGIS that powerful libraries such as GDAL, GrassGIS, and SagaGIS. And it can also use for educational and professional applications, and widely used for academic research mainly, and then environmental management. And by using open source software like QGIS, users can avoid vendor lock-in and have greater control over their data and workflows. Next. So here I've shown the some important open source software link. So this is the link for different tools and programming languages. That's I have shown. So I will show you on hands. So where the QGIS, R Studio, Panoply, Python, and I wonder navigation should download. I will show this later. Okay, next one. So this and I will introduce the open source data platforms. So before going to the open source data platforms, you should know that special data formats are available, which can be used by you. There is one is vector data formats, one is raster data formats. So vector data formats, these contain mainly shape file, SSP, that is define geometry, and SHX, which is define the shape index, and DVF, which is mainly shown the attributes data, and P.PRJ, it's positions informations. .PRJ from what is the positions are there, and .CPG is define the character encoding. There is different vector formats are available in the for a spatial analysis. That is shapefile one, that is JSON, and then KML, that is keyhole markup language, and GML, geography markup languages. Next one. So then raster data formats. What is the different types of formats are available through user community? That GeoTIFF, and that is that extension will be .TIFF and .TIFF, and it can be it is for raster data analysis mainly in remote sensing purpose, satellite, that is satellite imagery and digital elevation models as an example. And then ARDAS images, these are raster format available that in hexagon special for use ARDAS imaging software, and its extension is .img format. And then net serial format, this is common data form that is mainly available in .nc file, and this is widely used for climatology and meteorological purpose. And it stores multiple dimensional data such as temperature, humidity, and wind speeds. These are meteorologists are used this format only. Then HDF format. This is a hierarchical data format. It is a very complex data format, and it can store large amount of heterogeneous data. Then here I have shown that the satellite, which is used for remote sensing purposes, and their resolutions I have mentioned here. Their Landsat, the Landsat operations which launched from 1972 till date, they have launched different satellites, series 1, Landsat 1, 2, 3, like that way they have launched. So there is different. They have when before installations satellite in the space, they have set the different.
Just sorry to interrupt. We're getting a request that can the screen be made expanded, or is it that the participant and they can expand their own screen? For them, it's difficult to view.
Okay.
Is it better for everyone?
Yes.
Okay. Can someone else also confirm?
Yes, ma'am.
Okay, great. Also, Debashish, just see there is some query regarding the software in the chat.
Okay. Yeah, I will see. Continue, please.
So they have before sending the satellite, they have make instrument. When they make instrument, they have set some band informations. There is in Landsat 8-9, which is called land imager and thermal input sensor. There is two types of sensor are there. There is operational land imager, that is in optical regions, and this thermal infrared sensor, that is known as TIRs. So you can see that there's 11 number of bands are there, Landsat 8 and 9. They have contain continuous spatial information using the different wavelengths that is expressed in micrometer. So you can see that for coastal region, they have used coastal aerosol band, and then band 2 blue, then band 3 green, band 4 red, like that. They have named the individual band. So they have fixed the resolutions in meters. So you can see that only that panchromatic band, which has resolutions 15 meter, and others all the optical regions from blue to sweet, these are fixed within the 30 meter, and only you can see differences the resolutions of optical and thermal remote sensing. These are the thermal remote sensing which has resolution 100 meters. So it gives 30 meters. So for our especially for users need, so they have resampled these 100 meter data into the 30 meter data. So for in different types of analysis. Next one. So this is the Sentinel band data available. There is 12 bands are available for Sentinel platform, which is mainly used for optical remote sensing with the different central wavelength that is expressed in micrometer, and their resolutions are available. Here only you can see that optical regions that have very high resolutions. That is mainly blue, green, red. These are 10 meter, and the sweet band, which has 20 meter, and then water vapor and cirrus, sweet cirrus band, which is available in 60 meter. Next. This is the platform from where you can see the that Landsat passing ascending or descending order over the particular place. you can see this is the path when the satellite come ascending or descending order over a particular place. You can see the when suppose I have taken today observations. So next day, before you know that what is the temporal resolutions of Landsat 8 or 9, that's mainly available in 16 days intervals. That means 16 day today the satellite will pass for your particular place, and then next 16 day they will revisit that place. Okay, so their repeativity is 16 days only. So you can if you working with remote sensing, for any particular place you want to identify, so you working on that, so you need to know that which day the satellite will be passed. Suppose today is 9th July, today's past Landsat satellite will be passed. Then next you count the next 16 days when the satellite will be passed. You can browse there on the date. You can count. I think then you can use the laser count. Yes.
I just hope for all the participants now the screen is fine. If it is still small, please let us know. We can enlarge the size.
No, Jinath, I think it is okay because I am monitoring also, so it's fine.
All right, great.
Suppose there is a July. I said today is the 9. Today is the 9. In my place, the satellite will be passed. Okay, I have already seen previous day. Okay, so what is the next day? Is the satellite pass to your area? So you count the 16 days. You can check whether it will pass that day or not. It will like this. The tile. It's shown the in the tile. Okay, so this is the passing when the satellite will be passing in your particular place. This can you can search in your day there for your particular locations. So this is the path number. You remember that there is a path number for your suppose my study area here. The path number is 134. So you can see according to your area, the path number maybe your path is 198. So according to after 15 days, you can see the whether the satellite will pass that day or not. Okay. So here I have shown the some the good platforms for downloading the different satellite product which are available by USGS. That is known as Earth Explorer, and you can download the Landsat 8-9 data from here. Okay, so I'll show you the how to download the data, and I already given the link. I will show here. So this is the platform for downloading the different remote sensing product. So this is based on remote sensing product which you can download. Okay, so this is another data website. There is art data. You can search different types of data, including your MODIS data, the MODIS data, and it contains various informations like different types of vegetations, and also SOMI NPV data, and there is different net primary productivity also there. Okay, so I will cover later. So this is the most important site to download the if you want to work that regional level or global level. So this is help you to access the product. This is a Sentinel platform which are available in the which is available by Copernicus Sci-Hub. This is the mainly platform. The data agency, the mainly as a European agency, which is provide the open source data. There is mainly different Sentinel platforms are available. Sentinel 2, 1, and Sentinel 3 and Sentinel 5P also there. So I will show next. So this is the important links of remote sensing data product. So you can download the SMAP Modis Terra Aqua product from these links, which I have shown. Right? The global NDVI product that is mainly available at 8 km resolutions fortnightly, which can download from these links. Then Sentinel 2, then Copernicus browser. You can download any remote sensing data from which is provided by ESA using the Copernicus browser, and then Landsat acquisition tools already, which I have already shown. Then for climatological data and meteorological data, so this is the links are I have shown you that ERA 5 data, which is made available by the European Space Agency, means European ECMRWF. Then CHIPS data, which is rainfall estimates from rain gauge and sunlight observations, which is provided by Climate Hazard Centers, USA, Santa Barbara. So then IMD rainfall data, which is available at 25 kilometer, which is available in serial format. Then wall claim data, that is from where you can download future historical and current data also. Okay. So thank you. So this is my presentations. So now I will show you the how the data will be accessed from the different websites. You can show it here.
Stop screen. Stop share. Stop share. Now you can open Google. 1 minute. Share. It's okay. No, it's okay. You should get it.
So this is the US GS Art Explorer. From here you can download Landsat data and others data also. So you first go to the data set. So first of all, you have to log in here. So without login, I have shown you. So this is the data available. Using the different satellite and different sensors. It is AVS sensor, means advanced very high resolution satellite. Then you can download digital elevations different from Alaska, which is and GTOP and SRTM. These are mainly used for DEM, which is globally mostly used. This is SRTM data, and then
This is the topographic data, SRTM.
yes. This is mainly topographic data. This is shown the only aspect elevation, all these things. And then you can download land cover data, which are also available here. And then Landsat data. The Landsat data, there's a different level of data are available. So you can download from here. So similarly, the Landsat, there's different level of products available. So level 1, level 2, level 3, level 4, like that. So this is the Landsat correction to level 1 data. That is mainly it's a form of DN form. It's a scale DN product. So then level 2 product, it's basically the atmospheric corrective. You know, no need to atmospheric corrections for extra analysis. Okay, so you can directly use them. So I will suggest you this product you can use directly. That's at it and level 2 product. Okay. And then there is a vegetation monitoring data are also there. And NOAA, CDR, NDVI, Quick Bird, Quick Dry, and others also. Mode is also available here. So next. This is the art data login. From here you can download. Okay,
Just to give a heads up, you have 10 more minutes to complete and wind
okay,
up
I will
the.
complete within 5 minutes.
Sure, please take it.
Okay. So in art data login, you can download the Modis product, and Modis land cover data are also available. It's available in the sinusoidal positions. So it's you can correct these positions according to your interest. So from there you can art data, you can download Modis data and different land use land classes data, which can be used for regional analysis. Okay, for field analysis, you can use the Sentinel product as well as Landsat product. For regional and national scales, you can use this Modis data and SMAP data also. So this is a Sentinel platform, which is provided by ESA, European Space Agency. So you can explore the Sentinel data here. So this is the world climate data. This is mainly global climate and weather data available here. Historical climate, historical monthly weather, future climate data. Okay. So you can download different types of meteorological data. That's minimum temperature, maximum temperature, average temperature, precipitation, solar radiations, wind speed, and water vapor pressure also. These are available in different resolutions. That means up to they have expressed the data in terms of minutes, 10 minutes, 5 minutes, 21, 5 minutes, 30 seconds. Okay, these are available in 1 kilometer. That is very high resolutions. This T30 means it's available at 1 kilometer resolutions to 10 or 340 kilometers. Okay. And there is also bioclimatic variables are also available from this site. And elevation data at 10-meter resolutions, like that. This is the global GIMS NDVI data, which is available fortnightly. So they have developed this product from 98 to 2022. So I have already shared the link in the PPT. So from here you can download this data. It is mainly available at 9 kilometer resolutions. If you want to analyze the trend of NDVI globally, so you can use this product. From this, you can also the anomaly analysis for future. So you can use this data product. Then ships rainfall data. This is the ships rainfall data are available. You can access from using this line, this link. So you can see that there is globally 2 monthly, 3 monthly, decade, monthly, and daily also available. Okay, annual also available. Countries. This is global, mainly global data set which are available. They have created using large number of rain gauge station. They have developed this product globally, daily, monthly. This is the IMD gated rainfall data that is available 0.25 into 0.5. That is mainly 25 kilometer resolutions. Okay, that is mainly available in grid format from 1991 to 2023. This data available. Okay, this is mainly yearly data, yearly rainfall data available for Indian region only. The IMD have developed for own product for Indian regions for different analysis forecasting. Then it's already shown. Then ERA 5 product. This is there is a lot of product available to download use according to user interface. So this is mainly developed by ECMR WF. Source analysis. Okay. You first for using you first go to the data set. Okay, data set. Then product type. There's different product types are available. There's climate, including climate indices, climate projection data, and institute observation also, reanalysis data, and standard observations and seasonal forecast data available. And there's real domains are available, including atmosphere, land. Okay. And then a special coverage. It mainly available for Europe because Europe they have given forecasted only for the Euro regions, and they made available for at global level also. So if you're interested on global level, so you download the by clicking on global. There is different data sets are available here. You can search here also. Suppose you want soil moisture data, soil moisture. So there is soil moisture gated data from 1978 to present. Okay, available. The in situ observation, meteorological and soil variables also available here. You can see there is different stations they have installed for USA only. Okay, USA and some other parts. Then if you want to download the land cover map, that is available here. The land cover classification gated map 1992 to 2022 are available, and they have classified different classes using the cropland with rainfed, cropland irrigated or post planting, and then different tree covers and shrublands, grassland. They have classified uh, 22 classes. They have classified within 22 classes. So it's available in graded format. That is only available in CDF. And this is horizontal resolutions will be 300 meter. Okay. And you can download this data from here, from 1992 to 2022. So this is a very heavy data set. So per file will contain 2 to 3 GB, 2 to 3 GB, like that, in this range. Okay. So you log in, and then you can download this data. Okay. And it can be available in it can be downloaded in GIF format, GIF file format. Okay, I think I cover all those things here. So thank you for your attention.
All right. Thank you. Thank you so much for making time to take this session. We really appreciate it. So if there is any kind of question
Stop share.
from participants, and we can take it. Otherwise, we have a 15 minutes break before we move on to our next session.
Okay, Jinath, I believe that there must be some queries. I think better
Yes.
because Debaish has been handling these data since long. So, and then as I told you that there are a very huge number of data which are available of different resolutions from different sources for different parameters. And so you please utilize the time so we can break for tea or whatever, no problem. But at least you have, I expect you have at least few questions.
Yeah, I do believe we have one question in chat as well. But I would again request participants switch on your camera, use the mic, talk to the resource person directly, ask your question in an interactive way. So we have something in chat as well. Someone, Amir Shinwari has asked, in Afghanistan situation, could we recognize the soil organic and moisture through GIS?
Okay, I
So-
can explain. I can explain that. So soil organic is difficult. Organic carbon, as I said, that it could be possible if only if you have some field scale measurements. Because without field scale measurements, only using the satellite data, it's very difficult. So I'm not sure whether you would be able to get one, because one thing you need to understand, soil moisture, I'm coming next. So one thing you need to understand, because these are some of the parameters, like say soil organic carbon, which are where the variations are very less. So we are not expecting, even for the Afghanistan soil, its variation coming from say less than 0.1% and going towards say 5% or 10%, it will not come. So it is only within a very small range, and that capturing the small range by using satellite data is something which one should not, you can say, dream of. But you can try, but that's not. So one thing you can do is that you can target a small region. You take some soil, some organic carbon data from the field itself, going for the sampling and then taking the data, and then try to relate it with the covariates which is available. And then once your model is established for a particular set of particular area, then you can expand it to a bigger area by using the same relationships. So that will give you some advantage that, okay, you understand the logic over which the relationship have been established, and then you are using it for a bigger region. So that's one point. You followed some of the literature on the digital soil mapping, understand that things, and try with your soil organic carbon. Yeah. The second is soil moisture. Yes, soil moisture, you can do that. So there is one check is that the soil moisture is very dynamic. So even if it is 1 day, difference will be very high. So the same case applies here, that you use some of the software, like say you can use the soil moisture for that sentinel, the whole range of sentinel 1 and 2. You can use the optical by correlate with the vegetation, or you can use the microwave by getting the soil moisture content bearing mostly of the bare or sparse vegetation conditions. Use some models and then map it. But in that case also, you need to have some validation. At least some point observations has to be done even if you don't have any soil moisture monitoring network. So even if it is not there, then at least for 1 or 2 times, depending on the satellite pass, you take observations and then you get into that your inbuilt model, try to validate it, and then you can use it for a bigger region. Yes, of course, it can be done, Nakibullah. I'm happy that you raised the question that we can make out that. Thank you.